Hello friends and my dear students, I welcome you all to my channel. This is part 7 video on the subtopic of thrust and pressure from the chapter of force and pressure. So this video is part of the playlist ICSE Physics for class 8, where I primarily discuss about the key concepts and formulas related to problem solving from all the chapters. In this part 7 video, I will discuss about what is thrust, the definition of pressure and the units of pressure. In the subsequent videos, I will discuss more about pressure created by a solid body, pressure exerted by liquids and gases, and their effects in future videos. So in this video, primarily I will discuss about the definition of pressure, which is based on thrust, the units of pressure, and in the next video, part 8, I will solve some problem based on this video. If this video if you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then subscribe to my channel, and in that case, do not forget to press the bell icon so that you will be notified by my future videos. Okay, so I have written down some few notes so that I can refer while discussing thrust and pressure. Okay, so we have already covered what is the force and what is the moment of force or torque, that is the effect of force, in all the previous videos from the chapter of force and pressure. Okay, so what is thrust? Thrust is force, but it acts perpendicular to the surface of contact. So as you can see on the left hand side, on the figure 1, there is a body of mass m kilogram. It is resting on a surface. In this case, the weight of the body, which is a kind of force, which will be m kilogram force, is acting vertically, that is perpendicular to the surface on which the body is lying. So this weight can be considered as a thrust, which is being so the weight of the body is acting as a thrust on the surface on which the body is resting. In the second figure, you can see there is a container. Container is having some liquid. It could be water, oil, milk, any other liquid. And liquids, since liquids have masses, the liquid will exert perpendicular force or thrust on the bottom of the container, as well as it will have some force acting on the side walls of the container, which will be perpendicular. So a liquid in a container creates thrust in three directions, that is the vertically downwards on the bottom of the container, and vertically horizontally in a vertically to the side walls of the container, that is horizontal. So this was the first one was thrust exerted by a solid body. The second one was an example of thrust exerted by a liquid. The third one, as you can see, the earth is surrounded by atmosphere, that is air. We have about, and this air, the height up to which we have air or atmosphere is approximately 200 kilometers. So this air, since air has some density and hence mass, it will have some kind of thrust or force on the Earth's surface. So the atmosphere or the air surrounding the Earth, which is known as atmosphere, the force it applies on the surface of the Earth is also vertical, as you can see in the diagram. So it also creates a thrust on the Earth's surface, which we known as okay. When I will discuss about what is pressure, we all know about atmospheric pressure. So the atmospheric pressure is nothing but the pressure created by the thrust of the atmosphere on the Earth's surface. So I hope it is clear what is a thrust. now what is the difference between a thrust and a force? On a surface let's say this is a surface, any surface. Now a force can act on this surface in any direction. This is a force, but this is not a thrust. But this force is acting perpendicular to the surface, So this is a thrust. But this is not a thrust, or this is not a thrust. So the force which is acting perpendicular or normal to the surface, that is a thrust. Okay. Now, how do we? So a thrust has an effect, as every thrust has an effect, and to measure the quantity of the effect of a thrust, we have a physical quantity known as pressure. That is, what is pressure? A pressure is a physical quantity which is a measure of the effect of thrust. That is, when we say to indicate whether thrust is having a more effect or less effect, we usually indicate that by the magnitude of the pressure. So if pressure is more, we say the thrust has a more effect. If pressure is less, we say the thrust is having a less effect. Now, what exactly is pressure? That is, what is the mathematical formula or definition of a pressure? Pressure is thrust per unit area of contact. As we know that a thrust is a force which is acting vertically on a surface of contact. So when a thrust is acting on a surface of contact, what will be the pressure? The pressure P, which is denoted by the capital letter P, is equal to the force, the vertical force or thrust that is acting on the surface, divided by the area of the surface or area of contact, which we denote by A. So the formula of pressure is P is equal to F by A, where F is a thrust, and thrust is again essentially a force. So it is a force by area. Now, from this formula, it is important to understand how the pressure and the force and the area are varying with each other. Now, in this formula, if you consider the force to be a constant, if force is constant, then clearly the pressure is varying inversely with the area. Pressure will vary inversely with the area, as the more the area will be, the less will be the pressure when the force is kept constant. And if you decrease the area, the pressure will be more. On the other hand, if you keep the area of contact constant, then the pressure exerted by a force, then the pressure will be directly proportional to the force being applied or the thrust being applied on the surface. So if area is constant, the more is the thrust, more is the pressure. Less is the thrust, less is the pressure. Okay. So this was how the pressure, force and area are varying with each other. Now, when we say that the effect of thrust is more, usually we mean the pressure is more, and when we say the effect of thrust is less, we usually mean the pressure is less. Okay, so that was all about the physical understanding of what a pressure is, thrust is, and the formula of pressure in terms of the thrust and the area of contact on which the thrust is being applied. Now let's see the units of pressure. Now clearly the pressure P, unit of pressure, so I can say unit of P will be equal to unit of F, which is force, divided by unit of area. Okay. Now let's first consider the SI unit. The SI unit, we know the unit of force is Newton, so it will be, and unit of area is square meter or meter square. So the SI unit will be Newton per meter square, which is also denoted as Newton, and we have the power of -2 in the meter. So this is Newton per meter square. Now this Newton per meter square is also termed as Pascal due to based on the name of the scientist. Okay, so what is 1 Pascal? 1 Pascal is 1 Newton per meter square. 1 Newton per meter square. Okay, now how do we physically understand what is the physical interpretation of 1 Pascal? Since 1 Pascal is 1 Newton per meter square, we can easily understand from common sense that it is the pressure being exerted by a thrust of 1 Newton acting on an area of surface, acting on the surface whose area is 1 square meter. This is 1 Pascal. Okay. Now there is a bigger version of unit of Pascal, that is kilopascal. As you know, small k stands for 10 to the power 3. So 1 kilopascal. 1 second. So 1 kilopascal is nothing but 1000 Pascal, that is 10 to the power 3 Pascal. Okay. So mainly the standard unit of pressure is normally Pascal or 1 Newton per meter square. If you consider the force, if you consider other units of force like kilogram force or dyne or gram force, and if you consider other units of area like centimeter square, then we can have various forms of the unit of pressure, like 1 kilogram force per centimeter square is equal to the force is 1 kilogram force divided by the area is 1 centimeter square. Now if I want to convert this 1 kilogram force per centimeter square to Pascal, then I have to convert kilogram force to Newton. 1 kilogram force is equal to 10 Newton, and 1 centimeter square, if you convert this to meter square, it will be 10 to the power minus 4 meter square. After simplification, we will get 10 to the power 5 Newton per meter square. So this is also one important formula. I mean, if you can remember, that is fine, but you should always be able to convert from one unit to other unit from the very fundamental unit of conversion. Like you must know all the conversion of force and area and length. So 1 kilogram force per centimeter square is equal to 10 to the power 5 Pascal or 10 to the power 5 Newton per meter square. This is one important result. Let's see if I want to convert, if I want to know how much Pascal is 1 kilogram force per centimeter square. Now what is 1 gram force per centimeter square? This is the pressure exerted or pressure created on a surface having an area of 1 square centimeter, where the force applied or the thrust applied is 1 gram force, which is basically the weight of a mass of the weight of a body of mass 1 gram. So 1 gram force per centimeter square is equal to I will first convert GF to kgf. I know 1 gram force is equal to 10 to the power minus 3 kgf and divided by 1 centimeter square. Now I know 1 kgf is 10 Newton, so this will be 10 to the power minus 3 multiplied by 10 Newton divided by 10 to the power minus 4 meter square. After simplification, you will find this to be 100 Newton per meter square or 100 Pascal. So this is also one important conversion formula you must know, or you should remember, that 1 gram force per centimeter square is equal to 100 Pascal. Let's see what will be 1 dyne per centimeter square. Now 1 dyne per centimeter square, this is nothing but a pressure created on a surface having area of 1 square centimeter, where the thrust applied on the surface being 1 dyne. So this is 1 dyne divided by 1 centimeter square. 1 dyne we know is 10 to the power minus 5 Newton. So 10 to the power minus 5 Newton divided by 10 to the power minus 4 meter square. After simplification, this becomes 1 by 10 Newton per meter square or 1 by 10 Pascal. So 1 dyne per centimeter square is equal to 1 by 10 Pascal. Now there is another very important unit of pressure, which is the atmospheric pressure, atmospheric unit, atmospheric pressure. This is basically based on the pressure exerted by atmosphere. Now the atmospheric pressure varies from the surface of the earth on various heights. The atmospheric pressure varies, but the standard atmospheric pressure, that is 1 atmospheric pressure is also in short termed as ATM. So 1 ATM is equal to the pressure exerted by 76 centimeter column of mercury. 76 centimeter or 760 millimeter column of mercury, whatever that column of mercury is creating a pressure, that pressure is considered to be 1 atmospheric pressure, which is equal to in Pascal 1.013 multiplied by 10 to the power 5 Pascal. So this is also one important formula you must know, that 1 atmospheric pressure is equal to 1.013 multiplied by 10 to the power 5 Pascal. So this was all about some units of pressure. Now that was all for this video. In the next video I will solve some problems purely based on the formula that pressure is equal to force or thrust divided by area of surface of contact, and based on the units of pressure and their interconversion. The problems will be very, very fundamental and basic. Let's see. And then after that video I will discuss about in more details about the pressure exerted by various solids and the pressure exerted by the liquids, and possibly pressure exerted by gases. And subsequent videos will be some problems based on them. So these videos are coming soon, so please stay tuned. If this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and in that case do not forget to press the bell icon so that you will be notified by my future videos. So thanks for watching, and until the next video, take care and bye.